Hello and welcome to this Algebra 1 course. I'm Mr. Blair and I will be your online tutor for today, or for the whole course. Now, first of all, one of the most basic concepts within algebra is the idea of a variable. First of all, in order to understand a variable, we have to know exactly what it is. So, in basic terms, a variable is a letter that is used to represent one or more numbers. Okay? Now, the numbers are the values of that variable. A variable expression would be a collection of numbers, variables, and operations. So, for example, if we had something like 8y, okay, then this would mean 8 times y. And the operation being used here is obviously multiplication. If we have 16 over b, that's basically 16 divided by b, and the operation being used here is division. Alright, same thing with addition and subtraction. Alrighty. Now, if you take a look at this variable expression of 8y, you will see that 8 and y are together in one term. A lot of students, especially before Algebra 1, were writing their multiplication signs like this, okay, with an x being used as multiplication sign. This is something that you really must stop doing, okay, because for one, the expression 8y is usually not written as this because now that we're introduced to variables, this can confuse people and it could look like 8xy, okay, which we do not want. Okay? So in order to do multiplication, either put the terms next to each other, have parentheses, or just put a dot between them. Okay? All of those signify multiplication, and it's much better than doing something such as this. Right? Now, replacing each variable in an expression by a number is called evaluating that expression. Every time we do this lesson, every time we begin this Algebra 1 course, I always have at least one student ask me, what does evaluate mean? What do you mean by evaluate the expression? I mean that you're going to use our three-step formula here. You're going to write the variable expression first. You are going to substitute your values for variables, and then you're finally going to simplify the numerical expression. Okay? This is all we have to do. So for instance, if we take our expression of 8y and we want to evaluate that expression when y equals 2, well, we've already written our variable expression, 8y. Now we substitute our values for our variables. So now we have 8 times 2. 8 times 2, simplifying the numerical expression, gives us a total of 16. That is all that I mean by evaluating the expression. That's it. Okay. So, for example, again, if we had 10 divided by y and y equaled 5, okay, all we would have to do, we've written our variable expression, substitute our values for variables, so put a 5 under there. 10 divided by 5, simplifying the numerical expression, gives us a total of 2. Right? Simple as that. Now, let's try and apply this in a few different ways. Average speed is given by the following formula. Average speed equals distance divided by time. Alrighty? Or you can just say AS equals D over T. Okay? Simple thing. So what we want to do is we want to find the average speed in miles per hour of a car that traveled 180 miles from Boise, Idaho to the Minidoka National Wildlife Refuge in 3 hours. Okay? Well, here's what we have to do. We've already written our variable expression, which is average speed equals distance divided by time. Now we're going to substitute our values for variables. Now, if you can see here, what is our distance in this case? It would be 180 miles. Okay. Now, what would be our time? 3 hours. Okay. So we've substituted our values for variables, simplifying that numerical expression. 180 divided by 3, 18 divided by 3 gives us 6, add the 0, you will have 60. Always remember your unit. Our unit in this case is miles per hour. So, we can clearly see from this that the average speed was 60 miles per hour. Okay? Simple as that. Let's plug this into a geometric expression. Right? We know that the perimeter of a triangle is equal to the sum of the lengths of its sides. So perimeter equals A plus B plus C. Alright? What if we have a triangle here whose A equaled 8, B equaled 15, and C equaled 17? Okay? So this is what we have here. We want to find the perimeter of the triangle, and the dimensions are all in feet. Okay? Well, what do? We've already written our variable expression, which is perimeter equals A plus B plus C. Substitute your values for variables. So perimeter equals 8 plus 15 plus 17. Add all those together. 8 plus 15 gives you 23, plus 17 gives you a total of 40. Remember your unit, 40 feet. That's all there is to that. Right? Let's try one more here, just so it sinks in. Okay? The simple interest that is earned by money P, which is called the principal, at an annual interest rate R for T years, is given by the formula simple interest equals PRT. Okay? And we know that that operation is multiplication because they're right next to each other. Right? So let's say that you deposit $650 at a rate of 8% per year. We want to know how much simple interest will you earn after half of a year. Alrighty? So let's try this out. We've already written our variable expression. Okay? Now we substitute our values for variables. Our principal in this case, the money that we first deposited, was $650. Okay? Now, what's our rate? Well, it was 8% per year. Now to make this a bit simpler, we're going to put these in decimal forms. Okay? So 8% in the decimal form would be 0.08. Right? And half a year, simply 0.5. Right? We multiply all of those together, we get a total of 26. So we can assume here that after 1/2 of a year, you will have $26 of simple interest. Right? So we've conquered our first goal here. Right? Now, writing the units of each variable in a real-life problem helps you to determine the units for that answer. This is called unit analysis, and it's often used in problem solving in science. Basically, when the same units of measure occur in the numerator and the denominator of an expression, you can simply cancel the units. Now, in real-life problems, you may need to translate words into mathematics. One way to do this is to use a verbal model. So let's say that you plan to go hiking in the Jedediah Smith Redwood State Park in California. You estimate that you'll hike at a rate of 2 miles per hour on a steep trail. Right? And the map that you have shows a round-trip distance of about 7.4 miles. We want to know how long it will take you to hike this. Alrighty? Now, what is our verbal model in this case? Well, ask yourself, what are we looking for? We're looking for how long it will take us, so obviously we're looking for our time. Okay? Now, in order to solve this, this is simply like our average speed here. We do distance, and we divide that by our current rate. Okay? So, this is our verbal model. Okay? Now, all we have to do is plug these in. T will be for our time. Our distance, as we know, is 7.4 miles. And our rate is obviously 2 miles per hour. Okay? We simplify the numerical expression. 7.4 divided by 2 gives you a total of 3.7. Thus, it should take you about 3.7 hours to hike this tree trail. Now, I want you to ask yourself, how did you know, or how did we know, that hours were the correct unit for the solution? Well, that's one thing we're going to find out. We're going to use unit analysis to basically find that. Alrighty? So what we do with unit analysis is we take our original model, which is time equals distance divided by rate, and we simply break it down from there. Okay? So what is our distance in this case? Well, it was 7.4 miles, so it's in miles. Okay? Now that is over our rate, which we know is miles per hour. To break that down even further, you have miles and hours. Okay? Now unit analysis, as we said, states that when two concurrent things end up in the numerator and the denominator of an expression, you can simply cancel out the units. Okay? So we have miles in both of these. Okay? So what we can do there is simply cancel them out. And then, what do we have left over? We have hours. So we know, based on unit analysis, that 3.7 hours is the correct solution and unit of this expression. That is basically our first lesson for this Algebra 1 course. And be sure to take the quiz and see what else there is. Alright? I hope to see you again later. So, thank you, and goodbye.